goes into these two spots right here.
Yeah.
Right? And you want to make sure that you have one of the lines pointing in this direction. So an easy way to think of it is that one line points into the chamber, because that's where you're going to be sending it. Because you could have this turned this way and it would still be captured into the thing. But we want to have it this way so that one line, when it's in here, one of these lines is facing us, so we can kind of have a good idea. We can see what's going on.
Yeah.
If it's turned this way, we don't see anything that's going on. Does that make sense?
Yeah.
So we want that indicator to disappear. This indicator tells us that the turbo pump is at its correct speed. And so what you'll see is when it gets close to the correct speed, for this one it's 1500 hertz, this is going to turn on, and this one's going to stay on for a little while. You want to wait until this one disappears. And then what you're going to do now is you're going to look at the pressure of the intro chamber, the load lock, and you're going to want to wait, okay? It needs to be at least below 5 times 10 to the minus 5. Any higher and you're going to make the main chamber dirty, right? I would actually prefer if it was even lower pressure. So if you're able to wait longer, that would be preferred, okay? As you've seen, we've only been waiting for about 5 minutes. I'd recommend waiting for about 10 to 15, okay? And you see it's kind of slowly going down in pressure. Now we're at 5 times 10 to the minus 5. This is the absolute highest I'd want you to open it. And I'm gonna show you why, okay? So if we open the main chamber, I want you to look at the main chamber's pressure here. And I'm gonna open the gate valve. And it's just climbing. Now it's climbed all the way up to, you'll see this is pumping down faster now, it's in the minus 6s.
Yeah.
It's because the main chamber is pumping the load lock. A lot of the gases are going into the main chamber, which is what we don't really want to have that happen. We want to have a clean chamber. And so I would really recommend not doing this. I'd want you to be in the minus 6s, would be ideal.
Okay.
But if you're in a hurry, I'm telling you, do not above 5 times 10 to the minus 5. That's the hard limit, okay?
Yeah.
I prefer it if you started out in the minus 6s, okay? Okay, so now what we have to do is we have to introduce the sample into the chamber. Now, just like in SEM, you have to make sure the stage is in a correct position, and then you have to bring the sample in, and it's a little bit more complicated, actually, to transfer the sample, and I'm going to show you that now, okay?
But we don't load the sample, right? We just load the holder, sample holder.
Yeah, we've just loaded the sample holder, and I did that because I want to characterize the growth rate of platinum for you, because you want to grow very thin platinum, and so we're going to actually want a growth rate that's very slow. Does that make sense?
Yeah.
Okay, and so we have to grow on something. We don't have a shutter at the sample. We only have a shutter at the sources, so we can't measure their growth rate without them open. So we need to have a sample holder in there to grow, or else we would grow on a quartz lamp on the back, which you do not want to do. Never grow without at least a sample holder in here. Okay? Yeah. So that's why I'm putting a sample holder in, but I'm not putting your sample in because I don't know what the growth rate is going to be. I'm trying to get a recipe that's going to work first. Does that make sense? Yeah. Okay. So what you want to do is, if you look here, that's the height indicator of how high the stage is. We want to make sure it's at least above 20 millimeters. I'm going to bring it down. You can see there's a little 20 right there.
Yeah.
So you want to make sure it's up above that 20. Okay? This right here is a QCO on an arm that moves in and out. You want to make sure that that's out of the way. And then what you're going to want to do is you're going to want to come over here and you're going to want to move the arm in to underneath the stage. It should be out of the way now.
Mm-hmm.
If you look in here, there's a little black mark
Yeah.
right there. That is where the correct position is to load the holder onto the stage. What I want you to do is before you get to that mark, I want you to slow down and I want you to feel. Like, you'll feel if you're going to hit into something. And if you are, stop, back up, figure out what's going wrong. Okay? Call me. And so I'm going to show you how you do this. You grab the carrier right here and you just gently slide it over. And now I'm going to slow down right about here. And I'm going to make sure I'm going to feel. I'm not catching on anything. There's no bumps. I don't hear the sound of metal on metal, any of that. And I'm just going to come up to that black mark and I'm going to stop.
Okay.
Okay? All right. Now, I'm going to come to here. Here's some controls. If you turn this on, that's a continuous rotation. Okay? There's an off position and then there's RPM. 10, 20, 30, 40, 50 RPM. That's going to continuously rotate the stage. We don't want to do that right now because we want to grab onto the sample with that rotation. And so what we're going to do is we're going to only use this knob right here. Up, down, clockwise, anti-clockwise. Okay? If you look, the arm is now in there with the holder right up underneath the stage.
Yeah.
And so what I want to do is I'm going to look and on the back here, we put it in this way. Remember I told you to have the line facing that way?
Yeah.
And so to load the sample in, it's got something that looks almost exactly like this on the inside. We're going to lower the stage down into the hole. And then what we're going to do is we're going to rotate it, and then we're going to lift up, and the holder's going to come with it. Does that make sense?
Yeah.
And so on the stage, you can look for this little pin right here and make sure it's lined up and facing towards us. If we had put this in the wrong way, right, like this, if this line was facing that way, the pin would have to be in one of these two positions. But since we face it this way, we can have that pin facing directly towards us. Does that make sense?
So basically we are trying to make it hold by the thing that this thing hold by the thing that it already has inside, right?
Yes. Yep. It's just like this in there.
Yeah.
And so it's gonna come down and grab. And so So you can see the pin is facing towards me. Having a hard time?
Yeah, from the top. Yeah. It's
Yeah,
coming.
I can move it back and forth.
Yeah. I can see.
Okay.
So this is going to control that.
It rotates this,
Yeah.
and it brings it up and down. If you look here, there's a little, you see that Sharpie marker? That corresponds to the locked position, all right? Locked into place. This screw that's right next to it right here,
Okay.
that corresponds to the unlocked position, like this.
Yeah.
Right? So if you're having trouble seeing in there, you can use these markers as a helper. Okay?
Yeah. So when we say that it's locked, we see that both of them lined right. the markers.
Yeah, so this marker would be lined up with that marker.
Okay.
That would be locked into position.
Okay.
Now that's not to say that it's locked in. You could be just like that, and that would show that angle, right? That's not locked in. Locked in is you're down into the holder, and then you rotate, right? Even worse is when you only grab a little bit like that, and then you start rotating it. You'll see that it'll be doing weird things, and so this takes finesse, dexterity, careful hand. Does that make sense?
Yes.
I don't want you to break the motor. I don't want you to drop the holder, okay? Because this could, if you don't get a good grip on this, if you kind of grab it a little bit, and then you lift it up, and then you pull the arm out of the way, but then don't want that to happen, okay? So, I'm gonna go to where the screw is. I'm lining that up with a marker. I can also see in there, I can see that little pin. And now what I'm gonna do is I'm gonna lower the stage to try to grab the sample holder. So you heard the little clunk? There is a little bit of motion here. We are kind of manipulating things.
Yeah.
So that's not the end of the world. But as you can see, you see how the sample holder, it's really high up on the stage.
Yeah,
you can no longer see this portion,
Yeah.
right? That's a good sign. That's telling me, see, because I'm still very near the screw, so I'm still in the unlocked position. I'm still in this slot here. But it's telling me that instead of being like this, I'm like this. I'm down and in the holder. And now I know I can rotate it, and it's gonna grab the holder, and I can then lift it out of position. Does that make sense?
Yeah.
And so that's exactly what I'm gonna do. I'm gonna rotate it. Now you see how they're lined up?
Yeah.
I'm gonna try to keep rotating it, and what's gonna happen is that these pins that are in the transfer arm, they're not gonna let this rotate. They're in those captive positions, and so you'll see it try, and it won't make it. Do you see what I'm saying?
Yeah.
And so,
And then we confirm that is.
you see how it's not letting it move anymore?
Yeah.
So that's telling me that it's locked into position. This can only rotate so much, and it's locked into position now. And what I'm doing to prove to myself that it's the case is that I saw, hey, this is really close to the sample stage. I can't see this piece anymore. So I know it's down into that space. And when I rotate it, it rotates to the correct position on there, and it won't go any further.
Okay.
And that's telling me it's locked in. Does that make sense?
Yeah.
It won't go past that anymore. No, I'm not like holding it and trying to really force the motor or anything. I'm just giving it a little test.
Yeah.
Right? And now all I'm going to do is I'm going to lift it up. And while I'm lifting it up, I'm going to take a peek in there, take a gander. Does it look like it's doing anything weird? Does it look like is it lifting up only one side? Is it doing anything weird like that? And it looks good.
So you are just testing that whether it's not lifting.
Yeah. And so if you take a look, the holder is now lifted up with the stage.
Yeah.
Yeah. Okay, now if you look, I'm going to rotate it. And I can see the holder. You see how the holder is rotating now?
Yeah.
And it's not like wobbling or anything. It's rotating very cleanly around in a circle. That tells me it's grabbed all three sides. It's not like just grabbed two of them and it's at an angle or something weird. You see what I'm saying?
Yeah.
So everything looks good. It's not falling off because of the rotation. So now I know, hey, it's probably good. I'm going to move it all the way up to 20. All the way up to 20. And then I'm going to move the transfer arm back out. you don't want to forget to move the transfer arm out, because the next step's going to be to close the gate. You can't close the gate with the arm out in the middle of it, right? Even the SEM, there's like sensors. There's like, oh no, you haven't pulled the rod back out. There's no sensors. If I had left that in there and I start closing the gate, this is all mechanical. It's just gonna start closing. And I've got a lot of mechanical advantage. You know mechanical advantage? So I could crush that arm in the gate valve, ruin the gate valve, ruin the arm. Not good. Okay? See, I'm going slowly. You don't want to go fast. Now look, the main chamber, it's still not amazing. 1 times 10 to the minus 6. It's dropping. But this intro chamber was dirty. We should have let it pump longer. Right? We're still in the minus 6s, which isn't amazing. Okay. So now we're at the point where we want to actually do some testing, and I say testing in particular because we don't have your sample in there. We want to design a growth that's going to do well for you, and you want a very slow growth. If we go to this. Right here.
Actually, there is a slow growth recipe.
0.2 angstroms per second. That's slow enough for you?
Yeah.
0.2? Let's test it. How's that sound? Because I want to show you how to be able to do that. And really, we should have recipes in the back of the book. I think I'm gonna bring another notebook in, and I'm gonna write down recipes in the notebook so people know approved recipes, tested recipes, right? Because I've gone through the work of testing some recipes. So, for example, here, I've tested zirconium, and I've done a 200-second growth that grew 98 angstroms, and so I know that my growth had a 0.49 angstroms per second, right? And the parameters for the growth were 20 SCCM of argon, so we're flowing argon into the chamber. We have a chamber pressure of 3 millitorr, and we have a RF power of 30%. That results in a 0.49 angstroms per second.
So we are trying to find this thing for my growth, right?
Yes.
My sample, right?
All right, and so what we're going to do is we're going to copy this, and we're going to see if it ends up being what we think it is. Okay? So the first thing I'm going to actually do is I'm going to grow zirconium. And do you know why? Any guesses why I would grow zirconium first? We're not trying to actually grow the platinum. Right, so zirconium is what's called a getter, Getter. It acts as a scintillation pump in a vacuum chamber, and so if I coat the inside of the chamber with zirconium, it's going to pull oxygen and water and any other stuff from the chamber onto the walls, and it'll stick to the walls. And so what that'll do is it'll lower the pressure in the chamber temporarily. Well, as the stuff comes back off the walls, the turbo pump can then collect it. And so what it's going to do is it's going to give me a better pressure right now, and that's eventually going to equalize to the pressure it would be at a long, if I was to pump with just the turbo for a long time. And as you see, pumping on the turbo, we're already down to 9 minus 7, and it was like 8 minus 8 before. And so it will eventually get to that, but we're going to try to give it a little helping hand is what I'm saying. All right? And so what I'm going to do is I'm going to look up a recipe for zirconium. Right here, it says 20 SCCM of argon, And so that's what I'm going to do. I'm going to type in 20. With argon, and you see it hasn't done anything yet. There's no argon in the system, but if I hit on, see the pressure, it's popped up. Right? That's because argon is flowing into the chamber right now. When I want to do growth, when I want to do sputtering, you need to have a pressure that is above 5 times 10 to the minus 3 millitorr, or 5 millitorr, 5 times 10 to the 3 torr. And so this isn't a high enough pressure, it's too low. We're not going to be able to ignite a plasma at this pressure. And also, the recipe calls out for 3 millitorr of pressure. And so the way we control the pressure is with a gate valve. Right here, a digitally controlled valve that has a stepper motor on it that controls the exact position of the gate valve. And so what I'm going to do is I'm going to try around a few different gate positions to get to the correct pressure. 1000 is wide open, right? It's pumping as much as it can. It's at a very low pressure. I'm going to go down to 400 and see what that does. You hear,
Mm-hmm.
That's the valve closing a bit. You see we've climbed up to 6, maybe 7 millitorr. That might be enough to ignite the plasma. We're going to go ahead and try. We're on the zirconium. It calls for 30% power. These RF power supplies are a little sensitive, so you always want to start the power supply at around 20 or 30% power. You don't want to start too low, you don't want to start too high. Because if you're too low, it doesn't have very good control.
Mm-hmm.
If you're too high, that's like slamming the gas on the car when you're trying to start driving somewhere. You know what I'm saying?
Yeah.
All right, so what you want to do is you want to eliminate the ramp, so turn that to 0, and then you want to type in 30% power, okay? And then what you're going to want to do is you're going to want to hit on. And it might not ignite because it's been a while and I might need to change something. Yeah, so you see there's an error. If you see this error, you're going to want to call me, okay?
Okay.
All right, the problem is that these are not set correctly. So let's try that again. Go to 0, and we're going to try to ignite at 30% power. Okay, so the problem that we're having is that we're trying to ignite at too low of a pressure. And so what I'm going to do is I'm going to lower the gate valve position to, say, 380. I'm going to try to bring it up to 20 millitorr. At 9, maybe 10, let's try like 360. 11, 12. The problem that we're having is that we're at a low pressure, which is hard to ignite a plasma, and there's likely an oxide layer that's built up on top of the zirconium that hasn't been used in a while. Okay? The way I could tell that is I looked at the power supply, and it started off, I said, 180 watts, and it had a pretty high reflected power, but it wasn't, we weren't getting an ignition, right? And so the power was going into the system, but we weren't igniting an actual plasma, and that's almost always indicative of being too low of a pressure when you're trying to first ignite. And so, let's go to 350. And you want to always look at this lower number here. These two are close to each other, but you want to use the capacitance manometer.
Mm-hmm.
Okay?
What is the upper number?
That is a convection monitor, and it's not as accurate as this low pressure. 30%. And we've got ignition. You can see there's the glow there. I'm going to go ahead and I'm going to close the window here. You never want to grow with this window exposed. You want to have the shutter closed, because if you grow metal on that window, I have to replace the window.
Something like that.
Yeah. That has a film on it that protects it.
Yeah.
This doesn't. Right?
Yeah.
Like I said, there's a lot less here to try to protect you from making mistakes. Okay? So now what I'm going to do is now that I've ignited the plasma, I had to be at a higher pressure in order to ignite it. I need to now go back down to the correct parameters. We still have 20 SCCM of argon, but our pressure is too high. We're at 16 millitorr. We need to be down to 3. Okay?
Yeah.
And so what I'm going to do is I'm going to open that gate valve back up. We've ignited the plasma, and it's going to stick around. It's not going to cut out until maybe below 1 millitorr. So we're fine to lower it back down. It's just hard to start it. You see what I'm saying? Mm-hmm. All right, so I'm going to try 400, let's say. That's like 8 or 7. Let's try like 430. 5, 4, 4.1. It's like 440. See how I'm going slower as I'm getting closer? I don't want to overshoot, because if I go too low, it'll cut plasma out. 440 is pretty close. 3.5 millitorr. It needs to be 3.0, not 3.1, not 2.9, 3, okay? And so let's try 445. And you'll find that it's going to be about the same gate valve position each time. There we go. So now I'm just going to double check. 20 SCCM of argon, 3 millitorr, and 30% power. So everything's good. I can now open up the shutter, and I'm going to give you a quick look. We have to be quick because we don't want to grow a lot of metal in the window. But if you take a quick look, so the shutter opened and it's exposed, and you've got that plasma light going on. Mm-hmm. We're now growing zirconium. See our pressure's dropped a little bit right there, 2.9. So our gate valve is open a little bit too much. I'm going to go back down to 448. And hopefully it's going to stop switching between 2.9 and 3. Okay? And so you're going to want to monitor this. When you do your actual growth, what you'll want to do is you'll want to... there's no timer there. Start a timer on your phone, I guess. I don't know why this is being weird. Usually there's a timer right here. Not super hot. Okay. So I just want to grow zirconium for a little while. It's going to coat the chamber in zirconium. It's going to maybe give us a little bit better pressure. Okay. Something else that you can do is when you actually do your growth, you're going to want to make sure to turn on rotation. And as you see, it's rotating very slowly now.
The disc is rotating?
Yeah, so the holder is rotating. That's very important because wherever your sample is in the chamber, it might be a higher growth rate on one side of your sample versus the other. And so you're going to want to put your sample maybe as close to the middle of the holder as possible and then rotate it. So it gets more uniform coverage. Does that make sense? So I'm going to want to grow for maybe 5 minutes, right? That'll give us a few nanometers of zirconium. And it's very important, I need to log that. So this is the log. Okay. So it is 11, 20, 25. I'm Henry. And first we're going to do zirconium. And we're doing 20 SCCM of argon, 3 millitorr, 30% power. And we're going to do 5 minutes at 0.49 angstroms per second. Is 14.7 nanometers. Right?
Yeah. So how do you know this rate?
I went and I looked in the past and I found somebody that I trust. Happens to be me. You see here it says density and Z ratio. That's using the quartz crystal monitor, which I'm going to show you in a second here. That's why we're doing this part as a part of the training. We're using the quartz crystal monitor, and I found I characterized the growth rate by setting all this stuff up, and then I grew on the monitor to see how much it would grow in a certain amount of time, and over 200 seconds, the quartz crystal monitor said it grew 98 angstroms, and so I just do the math and I say it's 0.49 angstroms per second, right? That's a pretty good starting point. That's a pretty good guess at what the growth is. I'd say it's probably plus or minus 10% because it's a QCO. You really want to then go, if it's very important that your film is an exact thickness, you're going to want to characterize the actual thickness and come back out an actual growth rate, right? Because let's say I grew this 14.7 nanometers, and I go to the profilometer and it actually is 12, right? Well, I actually want 14.7, so I would say that's no good. I'll grow another one, and I'll grow, instead of 5 minutes, right, it actually grew 12 nanometers. I want 14.7, and it only grew 12. So I'm going to grow for 6.125 minutes, right? Mm-hmm. So what I'm trying to say is this is going to give us a good idea of what the growth rate is. It's within a few, tens of percentage. And so if you're growing electrodes, and you want your electrodes to be exactly 5 nanometers, well then you're going to want to characterize it. But if you just want your electrodes to be thin and the same thickness each time, maybe you don't need to characterize it. You see what I'm saying?
Yeah.
If you need to have electrodes that are 80 to 120 nanometers thick, just grow to 100 and you're good. Does that make sense? All right, it's been 5 minutes. I'm at a low power, so it's safe to just cut it off. And then I'm going to close the shutter. Okay? It's usually good to, after you've done doing a growth, turn off the argon and then open the chamber valve completely. That's going to pump the chamber out.
Okay,
right?
so one question. When you change these values, like 480, 490,
Yeah.
what we are doing?
Here. So we've got a vacuum chamber right here.
Yeah.
On the back of the vacuum chamber, we've got this massive turbo pump, right? And right here we have a stepper motor that's operating a normal gate valve. And so all this stepper motor does is it winds it up or winds it down, and it opens and closes that gate valve.
Okay.
But because it's a stepper motor, it can do it to a very precise position. And so when I say 448, 447, 446, that's 44.6% open. 44.8% open. Does that make sense?
Yeah.
And it's not linear because it's like it's a circle and how far open it is, but you get a feel for what it's doing. You see what I'm saying?
Yeah.
Now, remember when we first closed that gate valve there? It got to 1 very, very slowly. Now that we've grown zirconium, because it's a getter, it's actually going down lower in pressure pretty quickly. Does that make sense? It's cleaned the chamber up some. And not cleaned it up, it's to say it's removed stuff. Cleaned it up to say, that wall's dirty, I'm gonna coat it with paint. See what I'm saying? The stuff is still gonna come back off, but the turbo pump's gonna be working on it when it comes back off. Does that make sense? Okay. So now what we want to do is we want to characterize a platinum growth. And so what I'm going to do is I'm going to rotate. I'm going to turn this rotation off first. I'm going to rotate this QCO, quartz crystal monitor, out to be right underneath the sample. And so I need to make sure that this sample stage is up high. And now I'm going to rotate this in. You see I turned it very slowly. And it's going to lock into a position because there's a screw right here.
Yeah.
Right? And so if you look in, there's now an arm that's come out underneath the sample stage, right?
What is that?
That is a quartz crystal monitor, okay? That's one of these, right? It's a BAW device, bulk acoustic wave. It's like a little tiny drum made of piezoelectric material. And the electronics is constantly banging on the drum. And as we grow material, as we grow platinum, it's going to collect onto the surface, and based on the speed of sound in the material that we're growing and the density of the material that we're growing, it's going to change the pitch of the drum. Just ever so slightly change the pitch of the drum. The electronics are going to sense that, and it's going to say, hey, you've told me the density of the material and how sound travels through the material. I think you've grown this much. Does that make sense?
Yeah. So far we haven't grown anything.
So far we haven't grown anything. And
What-
so
So what we have done, all those things in this setup, just clean up.
that was just cleanup, and you don't normally have to do that.
Okay.
I'm just trying to give you as much information as I can about this equipment, right? If you have a getter like this and you care about the pressure in the chamber, that might be something that you want to do, okay?
Yeah.
If you're growing a sample that's just electrodes, like maybe you want to grow platinum electrodes that are thick and you're just using them to carry electricity, fine. If you're growing your 4 nanometer, very, very precise platinum and you want to make sure it's clean, you might want to clean the chamber like this before you do it.
So this all is the cleaning process.
Yeah, you might want to do this.
Okay.
Okay? And so the process would be, you're going to put in the empty carrier, you're going to grow 15 nanometers of zirconium, you're going to take the carrier back out, you're going to put your actual sample in, you'll put it into the intro load lock, and you'll let it pump for a while. You might let it pump for 20 minutes because you don't want to get the chamber dirty again, right? And then you bring your sample in and you might have a really good pressure and you might be able to grow a very clean platinum.
Okay.
Does that make sense?
Yeah.
Okay. So, we want to characterize the growth rate of platinum. And so I need to tell the quartz crystal oscillator with the density and how the sound travels in platinum. And so what I'm going to do is I'm going to go to program. I'm going to click next. Density 21.4. It looks like somebody probably did platinum before me on this. Tooling ratio is set to 3.99. Z factor is set to 2.5. And final thickness doesn't matter. Okay, I'm gonna hit 0. And so now what I'm gonna do, the tooling factor is just a multiplicative factor. And so I've set it to 3.9 so that it gives me a rate that is 3.99 times what the actual rate is. And that is just assuming on some chambers, you might have your quartz crystal monitor very low, very close to the source. And inverse square law would tell you it's gonna grow on the quartz crystal monitor faster, right? Because it's closer to the heat. It's just like a fire. If you're close to the fire, you got a lot. If you're far away, you got a little. And so what the tooling factor tells you is if you set it to a high number, that would be like saying I'm telling the equipment that my QCO is really far away compared to the sample. If I set it to a low number, that would be like telling the QCO you're really close. Only report half of the signal because you're square root of half the distance. Does that make sense? Okay. So, I want to set up to the settings that I have here. Let's see if we have